Hello, my name is Stefan. Welcome to today's lecture on developing a remote access Trojan for educational purposes. In this lecture series, we will explore the fundamentals of creating a RAT using Python, and today we will focus on the server-side implementation of it. So, a remote access Trojan is a powerful tool that allows authorized or unauthorized users to remotely access and control computers over a network. It can be used for various purposes, such as penetration testing, network administration, and remote troubleshooting. So, however, it's important to approach its development and usage responsibly and ethically. And in this lecture, we will dive into the server-side code of our remote access Trojan, and we will establish a network connection between a server and client, allowing us to send commands from the server to the client machine and receive the outputs back to the server's terminal. We will then walk through each line of code, discussing its purpose and functionality. So by the end of this lecture, you will have a solid understanding of the server-side implementation of our remote access Trojan and how it enables remote command execution. In this lecture, we will continue our journey by developing the client-side code, completing our remote access Trojan implementations. So remember, the purpose of this lecture series is educational, emphasizing responsible and ethical use of such tools, and it's essential to respect the legal boundaries and obtain proper authorization before conducting any activities related to hacking, penetration testing, or network security. So let's get started with our exploration of remote access Trojan development, starting with the server-side code here. And together we will learn how to create a functional remote access Trojan that can execute commands remotely and receive outputs in the server's terminal. So feel free to customize this code here. And for this lecture purposes here, we will delete this code. Actually, we will write the same code to the previous lectures for the messaging application, but it will, for some here, it might be watching from all over the lectures again for this section, and that's why we're gonna delete the codes here and we will write them again for educational purposes here. So we will explain this again and more depth here. And now what we're gonna do is we will write firstly import the socket here, import socket. So here we will also if name again, if name here, two equality signs, and again main here. And after that we will create a socket object for the server in order to do that. So we will again use the same variable hacker server socket here, and socket dot socket. That's it. Again socket.af init for TCP IP version 4. And also we will also use the socket dot sock stream in order to use the TCP protocol. And after that we will need to define the IP address and port to listen on. We will use IP to listen. It's gonna be 0.0.0.0. We will listen all available network interfaces, and the port is gonna be again the same port 8788 here. So port here, port 8788. So here we will need to bind the socket to the IP address and port. So we will create a new tuple, my socket address here, and we will create the first we will pass the IP to listen and then port here. And after that we will also bind this variable tuple here with this bind method, my socket address. And after that we will need to listen for incoming client connections. So here we will set the maximum client connections or client queue for 5 listen here. And after that we will print to the user that we are listening to all incoming client connections. So listening to or listening for all incoming client connections here. And that's it. And after that we will need to, if there's a client connection, we need to accept the client connection when it arrives. So in order to do that we will use the client socket, and here client address here, and we will equal to hacker server dot accept, and after that we will print the client IP address and port, and we will know that what the client and port we are working on. So connected to, or actual new connection, and here we will write the client address. Actually it was a it was client address and client it was a client address and client socket. Actually it's right, only client address only, so we know the port already, or we can also use this port. That's it. So here we will write the client address and port like this, and after that we will need to write a while loop. So while true, we will write the prompt the server operator to enter a command to execute on the client. In this case, the server operator is rv, and so now we will the command here. So command, and we will input some commands here, and we will notify that enter command to execute on client here, and here or type exit or exit to quit here. And after that we will send the command to the client. We will client here client socket dot send and command that encode here. Actually, instead of writing the plural, we can just use the command here instead of commands, and we will here we will check if the server operator wants to exit here. In order to do that, we will just turn the command to lower, because the server operator might write exit like that, or with uppercase E here and then down lowercase xit here, and that's why we will turn it the command to lowercase to check the proper here and exit. That's it. And after that we will break the loop here if this condition occurs here. So now we will need to receive the response from the client. So response here, client socket. We will not use that response here, but for next lectures we will need that here. Decode, we will also need to decode here if there's any response arrived. And after that we need to print the output from the client on the server's terminal. So print here, we will use the format. So output from client command line, and here after that we're gonna use a new line, and after that we will print the response. So here since we completed our application, now we will close the client and server sockets. Client socket dot close here and server socket dot close. That's it. Close here. Now that's actually run current while, and as you can see, it's listening for all incoming connections. So if there's a connections arrived, now we will enter some commands here. In this case, it will do nothing because there's a no connection into our machine here. So now I will explain all of the codes here. It will not take a long here. So firstly, we imported the socket. With this code, we import the socket model, which provides low-level network functionality. Here, as you remember, we are with this if name equals main, we are checking if the script is being run directly and not imported as a module. And here, as I explained in previous lectures, this hacker server socket variable, we are creating this socket EF inet here to creates a IP version 4, and this creates a TCP socket object for the server, and we are here specifying the IP address to listen on using this 0.0.0.0 means that the server will listen on all available network interfaces. This is the port. We are specifying the port to listen on. You can change this to any available port number. And here we are my socket address. We are here combining the IP address and the port here, IP address variable and port variable into a tuple to bind the socket. And here we are with this code we are binding the socket to specify the IP and port, and here we are enabling the server to listen for incoming client connections. And the 5 parameter that we wrote here specifies that the maximum number of queued connections. And after that we are printing here, and after that we are accepting a client connection when it arrives and returning a new socket object for communication with the client and client's address. And after that as you can see here, we have the command input, so we are printing just here. And so after that we are inside the while loop. With this here, we are prompting the server operator, in this case us, to enter a command to execute on the client. And after that here client socket.send command encode here sends the command to the client after encoding into bytes. And after that, if this line of code here checks if the server operator wants to exit, if so it breaks out of the loop. And here on the response here we are receiving the response from the client, and 1024 parameter specifies the maximum number of bytes to receive. And here we are printing the output from the client on the server's terminal. And here we are closing the socket for the client connection, and we are closing the socket for server socket. So this code here covers the server side code explanation. It sets up the server to listen for the client connections, prompts the operator for commands to send to the client, and prints the output received from the client. So in next lecture we will also develop a client side of the application here, so I'm waiting you in next lecture.